Today, let's walk through the construction process step by step and answer a very basic question first. Where does a building actually begin? The answer is simple. Construction always starts from the bottom, from the foundation. Before anything can be built above ground, we first have to deal with what's happening underground. And to build a foundation, the very first thing we need to do is excavate the ground. We dig a large pit so that workers and construction equipment can go down into it and start building the underground structure. This pit that we excavate is called a foundation pit. In everyday engineering language, we usually call it a deep excavation or foundation excavation. Now, let's think about this for a moment. If we dig a big pit in the ground, what happens to the soil on both sides? Naturally, the surrounding soil wants to move. Under its own weight and pressure, it can slide, collapse, or even cause serious accidents like landslides or cave-ins. So the key question becomes, how do we keep this pit stable? The solution is to build retaining or support structures around the foundation pit. These structures hold back the surrounding soil and prevent it from squeezing into the excavation. Collectively, we call these systems foundation pit support structures. There are many different types of support structures used in engineering. Some common examples include board pile walls, soldier pile walls, cement soil mixing piles, gravity retaining walls, and others. But today, we are focusing on one of the most important and widely used systems in modern urban construction, especially for high-rise buildings. This system is called the diaphragm wall, also known as the underground continuous wall. So what exactly is a diaphragm wall? In simple terms, it is a reinforced concrete wall constructed underground around the perimeter of the foundation pit. Its job is to act as a temporary or permanent retaining structure while we excavate and build the basement and foundation inside. Now let's talk about how a diaphragm wall is actually constructed. Before we start excavating the main foundation pit, we first construct a continuous reinforced concrete wall around the planned excavation area. Only after this wall is in place do we start digging the soil inside. But even before the diaphragm wall itself is built, there is an important preparatory step. On both sides of the future wall alignment, we first build what are called guide walls. Guide walls are shallow reinforced concrete walls, embedded a certain depth into the ground. They serve several important purposes. First, they help retain the soil at the ground surface and prevent collapse when excavation begins. Second, they provide accurate positioning. The diaphragm wall must be built exactly where it is designed, and the guide walls define the alignment and thickness of the wall. Third, guide walls help with slurry management. As we'll see in a moment, slurry plays a critical role in diaphragm wall construction, and the guide walls help store and control it near the ground surface. Once the guide walls on both sides are completed, we can begin excavating the trench for the diaphragm wall. This trench is very long, very narrow, and very deep. Because the wall itself can be hundreds of meters long, we don't excavate it all at once. Instead, we divide it into small sections. Each section is called a panel, or sometimes a trench segment. We excavate one panel at a time. After the soil in a panel is removed, we install a special steel element called a stop-end pipe or joint pipe. This pipe has a special tongue and groove shape, which forms a clean and strong joint between the current panel and the next one that will be constructed later. At this point, it's important to understand one key thing. After the soil is excavated, the trench is never left empty. Instead, the trench is immediately filled with bentonite slurry, which is a thick, viscous liquid. Why do we use slurry? First, slurry provides lateral support. It balances the earth pressure from the surrounding soil and prevents the trench walls from collapsing. Second, slurry helps with cleaning. During excavation, soil particles, sand, and debris naturally fall to the bottom of the trench. These need to be removed to ensure good construction quality. To do this, we use a slurry circulation system. The slurry is prepared in a slurry tank on the ground surface, usually using water and bentonite. This system includes a slurry tank and a sedimentation tank. Pipelines connect the slurry tanks to the trench, and a slurry pump keeps the slurry moving. As the pump runs, slurry is drawn up from the trench and sent into the sedimentation tank. As the slurry slows down in the sedimentation tank, heavier soil particles settle to the bottom. Cleaner slurry then flows back into the main tank and is pumped back down into the trench. This continuous circulation keeps the slurry level stable while gradually removing debris from the trench. This process is known as trench cleaning. Once the trench has been cleaned to the required standard, we move on to the next major step: installing the reinforcement cage. Because the trench is extremely narrow, often only a few dozen centimeters wide, it's impossible for workers to enter and tie reinforcement inside it. So instead, the reinforcement is pre-assembled above ground. Steel bars are tied together to form a large, rigid structure called a reinforcement cage. This cage is then lifted by a crane and carefully lowered into the slurry-filled trench. On the reinforcement cage, you'll notice a vertical pipe running along its length. This is called a grouting pipe. After concrete is placed, this grouting pipe allows cement grout to be injected into the bottom of the wall. Even with careful trench cleaning, some fine debris may remain at the base of the trench. Grouting strengthens this zone and prevents weak layers from forming at the bottom of the diaphragm wall. In many projects, this pipe can also serve as a sonic testing tube, which is used later to check the quality and integrity of the concrete wall. Finally, once the reinforcement cage is in place, concrete is poured using the Tremie method, displacing the slurry upward and forming a solid reinforced concrete diaphragm wall. And that's how a diaphragm wall is constructed, step by step, from the ground surface down into the earth, providing a safe and stable environment for deep foundation, excavation, and high-rise construction.